Now let us consider in detail the function block architecture as it is introduced by IEC 61499 standard. So, the development of 1499 standard was motivated by the need to make automation systems more intelligent. And one of main features of the intelligence is ability of automation systems to be reconfigured in a faster way with less effort spent on software rewriting. So as a result of that vision, the idea of intelligent mechatronic component has emerged, where every mechatronic component is seen as a device that has sufficient functionality embedded in it and programmed in embedded control device, or represented as a software component that is executed elsewhere. And this intelligent mechatronic component can be provider of services to the entire application or to other components, so that the entire automation system will be assembled as from building blocks from such intelligent components in easy plug-and-play way. So to capture the functionality that is provided by such a component, a standardized software component notion is required, and the existing component prototypes in IEC 61131, which are function blocks, was found insufficient for capturing all the required functionalities of intelligent mechatronic components. That is why new function block concept of 61499 was proposed. So one of the main requirements to such components is seen as the ability to talk to each other. And consequently, software components need to be equipped with a mechanism in which the code that is residing in one of such components can easily send messages to other components. So, like shown in the slide here, if we have component CMP1 that contains some sending data code, the data is formed into a message, and the message is transferred to another component CMP2, and then maybe one more, another batch of data is sent to component CMP3. So IEC 61499 provides all features needed to implement this vision of peer-to-peer communicating components. And in this screen, you see the library elements that are defined by part 1 architecture of the standard. And these include function block type declarations over here. These 3 function block type declarations, which are basic function block types, composite function block types, and service interface function block types. In addition to function blocks, which are main component concept of IEC 61499, there are structures which can be built from function blocks. These are sub-application type declaration, system configuration, and there are auxiliary structures that are required to build models of distributed systems, such as resource type declaration and device type declaration. In addition to that, there are structures required to create function blocks or structures of function blocks, which are data type declaration and adapter type declaration. So in the remaining part of this class, we will consider these structures in detail. So first of all, 3 kinds of function blocks that are defined by IEC 61499. These are basic, composite, and service interface function blocks. So the basic function block is a main instrument of a software developer. is seen as a way to encapsulate algorithms in different programming languages into a component that is ready to work in different conditions. And for that, it is equipped with an execution control chart. That is a state machine that is calling algorithms based on arrived events and current state of the data. Also, one should note that basic function blocks have internal variables. Algorithms work over internal variables and over input and output variables. Another kind of function block that is also intended to be used by the application developer is composite function block. So with the help of composite function block, we can create more complex software structures that are composed of instances of other function blocks connected with event and data flow lines. So same as basic function block, composite function block has interface consistent of event and data inputs and outputs, and instances of other function block types. But the composite function block does not have internal variables. Last but not least, there is a service interface function block. Service interface function blocks are intended to be developed by device vendors, so they play a role of device drivers, of hardware interface to different capabilities of hardware. And they are not intended to be developed by application developers, but application developers use their services, include service interface function blocks into their programs in order to interact with standardized services of devices. Each function block kind, first of all, has an interface, and this interface has a bit peculiar structure as compared to usual IEC 61131 interface. So in addition to data inputs and outputs that are located in the lower part of this graphical representation of function block, in the upper part that is called header, we have event inputs and event outputs. So we will discuss later what are those events. Events are used as abstraction of instantaneous happening that activates function block or is emitted by a function block to activate other function blocks. And in addition to events and data inputs and outputs, there are vertical lines connecting event inputs with data inputs and event outputs with data outputs, but not necessarily with all of them, maybe only with some of them. So those data inputs which are connected to a certain event will be sampled when that event arrives at the function block, and others will not be sampled. So if a data input is not connected to any event, it will never be sampled. And we also should remember that function blocks can be activated only by event inputs arriving at its input interface. So all three kinds of function blocks, basic, composite, and service interface, they all have a similar kind of interface. So, just to reiterate, what is an event? On the one hand, event is used as abstraction of some instantaneous happening that serves to activate function block. If we look into a familiar example of Boolean variables, we could say that both rising edge and falling edge of a Boolean variable can be interpreted as events. So these are shown, depicted here by vertical lines in this timeline. So events do not have any duration. So it's assumed that it's very short occurrence, and during that the events are represented by a Boolean value of 1. So it can be checked in the conditions in the program. If event didn't occur, so the value will be 0. If event did occur, the value will be 1. So let's repeat. Function block interface consists of event and data inputs and outputs, and event data associations. So only those data that are associated with event, like for example in this case we have event rec, event input rec, that is associated with all three data inputs QI, IN1 and IN2. So they all three will be sampled at the occurrence of event rec. Okay, now let us see how our dream about communicating, peer-to-peer communicating software components is implemented by mechanisms of IEC 61499. In IEC 61499, each datagram that is sent by a function block to another function block is implemented by means of an event output and its associated data outputs. So when we connect this function block with a corresponding recipient block by event and data connection lines, and the recipient function block has exactly the same matching event and data association, then we can send the datagram and it will arrive to the destination block. And the same applies to any other datagram that can be generated by the same function block. So it can be many of them. And for each of them, we need to have a dedicated event output and its associated data, which are connected to the corresponding inputs of another function block. And as we can see here, some of the data outputs of CMP1 function block can be shared between several datagrams, as the output B in this case. What you need to remember is that when you define a function block, you define its type. And this type can be instantiated many times. So this will be creating exact same copies of the same type. You give them different names and use them in your program, in your application. Like for example, it is done here on the right hand side of the screen. On the top, we see the definition of basic function block type named basic FB, and in the bottom we have a small application, a network of two function block instances. One is called FB1 and another instance is called FB2. And these are connected with events and data connectors. So when we create the function block type, we define its interface, and in the interface we define its event inputs, event outputs, data inputs, data outputs, and event and data associations, which are these vertical lines. So when we use function block types as instances and we connect them with event and data connections, we need to remember that the way how the event and data will propagate depends on the definition of the type. Like in this example, let's see what will happen when the output event of a function block instance FB1 is emitted. So in this case, the first thing is that the outputs associated with this output event are sampled and like put on the line. So, but which are the outputs associated with CNF? We go to the type definition and see that there are three of them. There is a QO, there is a and there is a C, right? Three data outputs associated with this one data with this one output event. So then we go to the application, and what we see is that only out of these three, only one of these, A, is actually connected to the other function block. So this value will be sampled when this event is emitted. Value of A will be sampled and will be put on the line, right? So then event is transmitted to the other function block, to its event input rec. So this event appears at the input of function block FB2. Function block FB2 gets activated by event. Remember that there is not only way to activate function block is by input event. And at that moment, data variables, data inputs, which are associated with rec, will be sampled. And what are the inputs associated with rec? Let's take a look at the type definition. These are three. This is QI, D, and E. And out of these three, only D is actually connected. No, it's also E is connected, but E was not sampled at the time when event was emitted from FB1. So D will be sampled, and the refreshed value of FB1A will be passed into FB2. But as far as E is concerned, something will be sampled and some value will be passed into FB2, but it will be not the latest refreshed value of variable B from the function block instance FB1, because that one was not sampled at the output. Okay, so let's see another example of the same of a similar story, when we have two function block instances, and these two function block instances are connected with one event link and two data links. So we put in the same screen also definition of event and data associations. Usually it's not the part of application, but now just for to simplify our life, we put this vertical line here and here to see immediately with which data this output event and input event are associated. So when we emit EO event from FB1, what will happen? First, this event is emitted, and then the associated data outputs A and C will be sampled, and the refreshed values will be taken from FB1 and put on this line. So here and here, right? Then event will be transmitted to event input EI of FB2, and at that moment the associated data inputs will be sampled. So, and these are D and E. So D is connected to A, so this value, refreshed value of A, as a result will get into the function block 2, while B is not associated with EO, so there will be some garbage, and this garbage will be taken from the line. So it's undefined value. Garbage is undefined value, and will be taken from the line and also sampled as a value of new value of variable E. So you need to be thinking carefully about association of events with data when you connect two blocks together. Take into account those associations to not to be surprised if some strange value appears in your data variables. Okay, let's move on. And the last question is, what are the data types that are allowed to be used in IEC 61499 function blocks? So this, first of all, are usual data types of IEC 61131 standard. For example, the numeric data types for whole numbers like byte, word, integer, floating types, real, Boolean types for logical variables, string types for usual strings and byte strings, date and type types, and also user-defined data types like structures. They are also supported in IEC 61499.